Hello. Now you have to find the median household size from this table. As I said, a common mistake is to find the middle value. There are five outcomes, and some students are calculating, make mistake, are confused, and calculate and take the middle value and choose this over, of course, wrong. 3 is not the median, because the probability is not balanced. The probabilities on the left and on the right are not balanced. So let's balance them out. To do that, you have to calculate the cumulative probability, and it's easy. It's simple algebra, simple addition. For one, cumulative probability has only one probability. For two, cumulative probability includes two, so add these two. Then you get 61%. And now we are calculating the median, so you don't need to go further. That's it. So what we need is the smallest value greater than 50%. Already we get it. If you go further, you are going to get uh, like cumulative probability greater than 50%, but they are they are going to be greater than 61%. Right? You are only adding numbers. So anyhow, the smallest value among greater than 50% is the first one when you calculate the cumulative probability. So there is no reason to do any more than this. So the answer is 2. We want the smallest value whose cumulative probability is greater than 50%, right? Remember that, then it is easy. And as I said, the answer is not 3. And you may calculate probability smaller than or equal to 2, which is 61%. And if you calculate probability greater than or equal to 2, includes these four probabilities. And if you calculate this, it is 73%. So uh, it satisfies, number 2 satisfies the two conditions at the same time. The conditions for the median is satisfied, right? Okay, we learned how to calculate the median. And then a natural question is, why do we need it? Why do we calculate the median? And here comes the comparison between the mean and the median. So uh, when simply comparing these two is unfair, because the mean is much more important and more common, widely used, and has many more nice properties than the median. So almost always mean is better and easily acceptable and easier to understand and more people understand. So the mean is the first choice always, but there are some special cases where the mean could cause problems. That's when you expect some outliers. When there are outliers, the mean is severely affected, even if the number of outliers is small. So, small number of outliers, I'm going to give you more examples how the mean is contaminated by outliers. So, when there are outliers, a good alternative is the median. So the major advantage of using the median is that it's less sensitive to outliers. So even if there are outliers, median is more robust. But the problem is it's less popular and you have to explain. Many people don't understand what's the median, so you have to explain why you are using median, not the mean. And when you apply the median, it's less tractable. So the linear relationship example, the result from the linear relationship does not hold for the median, right? So median do not satisfy that relationship. So that means it's less tractable. Even in the simple case, the median does not preserve the linear relationship. So anyhow, Then let's study what is the outlier. Outliers. I will give you an example. Think about an hypothetical survey. Suppose that you are very curious about the average household income. So you surveyed 10,000 households. It's a large number. You met 10,000 people and surveyed their annual income, household income, and you get a nice result, which is $0.1 million. Simply, so assume zero point 0.1 million is the average household income. But you want to improve this. So you keep surveying more people, but you are very unfortunate and you met Bill Gates, randomly chose one person, but the randomly chosen person was Bill Gates, the previous Microsoft CEO, the inventor of Windows, the legendary programmer Bill Gates, the rich Bill Gates, and he is the 10,001st survey respondent. Then let's see the problem. His income last year was $12 billion, estimated by the Business Insider magazine. $12 billion. Okay. So you have to recalculate the average, including Bill Gates now. So using 10,001 observations now, if you recalculate the mean, it becomes $1.3 million. Without without Bill Gates, the mean was zero point 0.1 million, but after you include Bill Gates, it it becomes 13 times more, 13 times greater than before, just by one person in 10,000 observations. So it's clearly Bill Gates is an extreme outlier. Bill Gates is not an average person. He should not be randomly chosen. Just you are just unlucky. There is so because of that one person, you are screwed. So this data has no meaning. So if you say the average household income is $1.3 million, who is going to believe this? It's totally wrong result. Something is not right. It's just luck, misfortune, but that this is the problem of the outliers. So to prevent this, and also this is a problem of the mean. The problem arises because you are using the mean, even if you have outliers. Okay, let's go back to the previous example. In the population example, state population example, California is a super outlier, right? He's California is staying us like alone. So if there was no California, we could make the histogram nicer, cutting the graph here. But anyhow, California is a super outlier, and you may also think Texas is another outlier, or there is no clear definition. There is no academic definition of outliers. And here is New York, Florida. So anyhow, these states are uh, irregular, somehow irregular. So now then let's see what happens. Typo and what happens when we remove these guys. If you think California is an outlier, then you may better drop this. So like if you see Bill Gates, you may better drop him from your data. That's more accurate. It's ad hoc, but frankly, that's the right way. Anyhow, so I will do a very interesting, simple experiment. First, I calculated the mean and the median using all 51 states. So 51 states include DC. Mean was 6.05, and median was 4.34. And then I dropped California and use only 50%, 50 states. You're only using 50 states. We calculated the mean and median. Then the mean becomes 5.43, median becomes 4.09. So from the full sample, of course, because I dropped a big state, the average will be lowered. But how much it changes? Mean changes by 0.62, which is more than 10% of the median. I mean, 10% of the mean has been removed by one state. But median changes only by 0.25. It's not, you may think it's not small, but at least it's much smaller than the median, the change in the mean. Now, suppose you additionally drop Texas, and now you only have 49 states. If you use 49 states, the mean out of 49 states equals to 5.03, median equals to 3.83. So of course it drops again because I'm dropping the second largest state. So the average will drop, but the mean drops by zero point 0.4. It's another 8%, like quite huge. But median drops by 0.24. So again, the change in the median is smaller than the mean. So here you can say the mean is more sensitive to outliers. You may think the other way. So if you start from 49 states, and if you add Texas, if you add California, the mean and median will increase, but mean increases more than the median. So look at this. The mean is 503 without two states, but after including both, mean is 605. Increased by 1, but median increases by zero point 0.5. So the mean in this example, the mean is twice more sensitive to the outliers than the median is. So this is another example that illustrates the problem of outliers. Or I am going to give you another example where this problem may happen. Suppose that you have 11 observations as follows, like this simple 11 numbers. These numbers are your data. If you calculate the mean and median, you get 5. Mean is 5, median is 5. It's easy to see the middle point. But by mistake, when you enter the results on Excel, you typed two more zeros. You have to click 0, but you have to click it 3 times. And then it's simple typo in one observation. And in this extreme example, the mean becomes 95. But the median does not change. Median is not affected. So it doesn't matter even if it's 1 million, still the middle value when you order 11 numbers in this way, it does not matter it's million or billion, still the middle value is always 5. This is the reason why the median is less sensitive. It's not sensitive to outliers. So then come back to economics. Outliers are particularly important in economics. If you study biology, there are not many outliers. So, like say, think about like height or weight distribution. There are some like skinny guys or like chubby guys, but they are not super extreme. I have never seen 1,000 pounds guy. So these extreme guys do not exist. Like there is no Bill Gates in weights. But there are super rich guys in economics. Like think about super rich. Jeff Bezos, the Amazon CEO, Warren Buffett, Bill Gates, those guys like Elon Musk, like Mark Zuckerberg. Those super riches um, are exceptional. They are just exceptional, like irregular, extraordinary guys, not the subjects of statistical analysis. And also in farms, among farms, a few tech giants like Apple, Microsoft, Amazon, Google, are different. They are totally different from the others. So these guys may change may change a lot. And so also in financial markets, stock market crashes during crisis. When stock market increases, it increases like this, but when it drops, it plummets, like it crashes. So when it increases, it's about like 10%, around 10% a year. But when it drops, like it can drop like 50% a month, like 30% a year. So those are outliers, very different behaviors from the center. In those examples, you have to be careful and you may want to use the median instead of the mean. Or at least you may try the median uh, in addition to the mean. So, one example here is so between uh, 1972, I think 1972 to 2007, in the United States, the mean household income increased 95%, almost doubled in this like more than 30-year period, 35 years. But the median household income increased only 22%, right? So what it's so it like so it could be dangerous to say something if you do not read the median household income. If you say uh if you say the average household income increased twice, but someone may argue that that's not the case. The median increased only by 22%. I think this is more correct observation. And the reason is what you can see here is there are more outliers. Uh, the number of outliers increased in this period. So the rich becomes more rich, but the middle stayed quite flat. Like it grew a little, increased a little, but it's quite steady. So the income inequality increased. That's what we can conclude from these numbers. So because of this, the median household income and mean household income differ a lot. Differ a lot, like because of these guys, super rich guys. The poverty and for academic purposes, the poverty is defined based on the median household income. So when you see the mean income or the average in economic variables, you have to think about this problem. There may be outliers, so your mean could be misleading, maybe contaminated by outliers. So that's quite common in economics. That's why we learn the median. Okay, it became too long. I'm going to stop this video here and I will continue in the next video. Thank you for listening.